All right. I had an issue with the other live, so I had to switch over to this one. So hopefully you all switch over here. Hey, good morning, guys. Good morning. Sorry about I had an issue with the first live stream, so I had to switch over to another one. Good morning, Andy. Good morning, Chris, Vandy. Good morning, Molly. Good morning, Jared. Good morning, Kenny. Good morning, Taylor. Good morning, Miss Ellen. All right. Several of you are here. I'm sure some people are coming in. Are there any questions from 4.3 homework? I'd be glad to answer any of those right now. You just type what you have in the chat box if you have anything. Good morning, Jamie. Good morning, Jake. So right now, taking any questions over 4.3 homework. If you have any questions, I know you had the answer key with it, but if you have any questions, punch those in. Give everybody some time to get in. We'll probably start every time like 5 minutes after the live, so we're about 11:05, something like that. Good morning, Dawson. Yes, Karen. If you were to go to your files on Canvas under our class, you should see the answer key there. Good morning, Jesse. I don't know what your screen looks like, but if you go to Canvas, of course, I have a bunch of different classes here. And then if I click on files right here, that's everything we're doing over the next 3 weeks. So if you hit 4.3 notes and homework, that's the copy that you can print off. And down at the bottom should be an answer key right here. So that would be your answer key for that if you didn't get the hard copy. Sorry. Any questions at all on the homework? Right now is the best time for you to ask. I'm assuming that you all did that. All right. If there are no questions over 4.3, let's just go ahead and jump to 4.3 notes. Or excuse me, 4.4 notes. Jake, do you want to see number 8? I'm sorry, I just saw that. Yes or no, Jake, do you want to see number 8 on 4.3? Sorry, I just saw that come through. So Jake said something about number 8. So we'll just look at that. So if I say 1 over 5x squared times and then change that to 3x minus 3 over x minus 1. So keep, change, flip. And then we just factor everything. This side does not factor, but I can factor a 3 out of that, leaving me x minus 1 over x minus 1. That would cancel with that. 1 times 3 is 3 over 5x squared. And then remember, for your exclusion or your excluded values, you got to do 1, 2, and 3 on the division problems. So 5x squared equals 0, x minus 1 equals 0, and 3x minus 3 equals 0. Divide both sides by 5 there. X squared equals 0. So we know x equals 0 there. Add 1 there. X equals 1. Add 3 here. 3x equals 3, divide both sides by 3, and we get x equals 1. So my excluded would be 0, 1. Have my simplified version, have the other one. I don't remember who LJ New is. Who is LJ New? Sorry. Oh, Lonnie. My bad. Give me just 1 second. I just need to send this link out to everyone. Okay, so Jake, does that answer your question? Cool. All right, so now moving on to lesson 4.4 notes. All right, so this is all about yesterday. What we did was we were multiplying and dividing rational expressions. Today we add and subtract rational expressions. Hey, and just a tip, make sure you're always to the right on your live, because if your computer lags, it'll slow you down, so you may be a little bit behind. So okay, so when we're dealing with fractions, so basically these are fractions but with expressions in here. Okay, but we're going to work with these the same way we did regular fractions. Okay, so for instance, if you had something, let me grab a piece of paper. For instance, if you had 2/3 plus 3/4, the way you added these was to get the same denominator. Okay, so if you had like 2/3 plus 1/3, you have the same denominator. Then you can just add the numerators together and get 3/3. But when they're different like this, if you can recall, you had to say like 2/3 plus 3/4, and you had to get the same denominator. So this, they would share 12 as a denominator. Multiply that by 3, that by 3, get 9. Multiply that by 4 and that by 4 and get 8. And then you get 17/12. Sorry about that. Then you would get 17/12 by adding this plus this. So you had to get like denominators. Is the key to adding and subtracting rational expressions, just straight up fractions. So if you have like denominators, you just add. First step is just add the numerators. So like denominators, add the numerators. So notice here with number 1, my denominators are 4x plus 6 and 4x plus 6. So those denominators are alike. So the only thing I have to do is just to add the numerators. So it would look like this. 2 plus x minus 3. I've brought them together and they're all over the same denominator, 4x plus 6. So I've brought them together. They have same denominator, so I just bring them together. So now I can add like terms. So I have 2 and I have negative 3. So what is 2 minus 3? Someone type that into the chat box. What's 2 minus 3? Vandy, we don't because we're not multiplying these. They just become one denominator. They're the same. So when you're adding and they're the same, you just put it as 1. Andrew, did it say that yesterday that I need to approve you to view the video? I'm not seeing anywhere for me to do it. Okay. So, Jake, you said, would we do the same thing if it was minus? That's correct, but it may be a little bit different with minus. Okay. There you go. Thanks, Kenny. So, Andrew, you may, if you have like a personal account, you may want to get on it that way. Okay. So here we go. 2 minus 3 is, Taylor said, is negative 1. So I would say this is equal to negative 1 plus x over 4x plus 6. And this right here would be my final answer. Okay. Now, something I could ask myself here is, how are you, Andrew, how are you chatting? If you, it just won't let you watch it at all? No worries, Kyle. Andrew, I'm really not sure. The only thing I can think of is if you change your settings, but I don't know how you can chat and not watch the video. Normally it's the backwards. No worries, Kinsey. Normally it's backwards. Normally you would be able to watch a video but not chat. So that's what I'm thrown off by. Maybe try refreshing your screen, closing it, coming back in. And again, you can always rewatch it. Okay. Something to consider here is that we could factor this right here. We could factor a 2 out of this, but even if I factor a 2, it's not going to cancel. I can't do anything to the numerator. So I can't, and the go is because we're simplifying here. And yesterday, simplifying meant factoring down and canceling, but I can't factor anything out of the numerator, so there's no reason to cancel that. But what I will tell you, Andrew, either way, totally up to you, man. But what I will tell you within this, you could see the answer is this right here. So this, or on a test, if you saw this right here, that would be this would be correct as well. You would not have both of these as an answer choice, but you could see this opposed to this right here, because some people say, and it's a difference of opinion, some people say that this right here is more simplified because it's factored out. So just preparing you, you could see it either way. Okay, let's jump over to number 2. All right, so we ask ourselves with number 2, do I have like denominators? I have 4b squared plus 4b and 4b squared plus 4b. So like denominators are the same, so that means I just bring the numerators together. 3b plus 2 plus this numerator, b plus 3. And when you're adding, only thing you got to do is just bring those together. 4b squared plus 4b. Yeah, that would make sense, Molly, if you can't see the video. Oh, okay. Okay, so then from here, I have some like terms. I have 3b and b. Thanks, Molly. And 2 and 3. So 3b plus b would be 4b. 2 plus 3 is 5 over 4b squared plus 4b. Now here's my question to you all. I have 4b here and a 4b here. Can I cancel those two? Yes or no, and why not? Type it into the chat box. Can I cancel 4b here and here? Yes or no, and why not? Good, Vandy. Good, Taylor. We cannot cancel those because they are attached with addition. Okay, they're attached with addition. And very good, Adam. It's not being multiplied. Okay, it's not being multiplied. It's attached with addition, so I can't do that. I can't factor anything out of the numerator because they're not like terms here, so I can't factor out anything here. So that would make it pointless to factor. So I would have this as my final answer. But don't be alarmed if you saw this as an answer. 4b plus 5 over 4b times b plus 1. Don't be alarmed if like you saw that on a test and you're like, oh man, that's not what I have. It's just they factored the denominator. Which brings up another good question. Now can I factor this 4b? It's being multiplied and cancel it with that. Can I cancel this 4b and 4b? Answer yes or no to that. And why not? Good, Taylor. No. Someone give me a reason why it cannot. We can't. Jake says no. He's just copying off Taylor. Yeah. Well, if you notice, this 4b right here, the numerator is, again, a very good answer, Adam. The numerator is not being multiplied. It's being added to 5. While this is being multiplied by that, the 4b up here is still attached with addition, so therefore we cannot. Good to see you, Tara. Okay, so now let's go to number 3. So with number 3, here is our question. Do we have like denominators? And the answer, that's hypothetical, and the answer to that is no. So when you have unlike denominators, you need to get them alike. Okay? You need to get them alike. Now, if I was to show you what I did back here on this example problem at the beginning of class, notice I had 2/3 and 3/4. And I was adding those two together, right? Here's the work right here. And what I said was this. I need to get these to be the same denominator. So notice, what did I multiply 4 by? I multiplied 4 by what? 3, which is really the denominator of the other one. And what I do to the bottom, I have to do to the top. So that's how I came up with 9/12. And what did I multiply the 3 by? I multiplied it by 4. So it's like the denominator of the other one, 4. And what I do to the bottom, I have to do to the top. And I got 8 and 12. Now I have like denominators, so I just add the numerators. And got 8 plus 9 is 17/12. So we're going to do that same type thing here with these problems. We're going to multiply the first fraction by the denominator of the second one and multiply the second fraction by the denominator of the first fraction. So, step 1. I'm going to rewrite the problem with space. You may be saying, well, what does that mean? Watch this. So say k plus 3 over k plus 1, but I'm going to leave some space right here and say plus, the plus sign's coming from that, plus, and then I can just write that like this, 3k over 2. So rewrite the problem with space to the right of this, and you naturally have space to the right of this. Hey, give me a smiley face if you can hear me. If you can hear me, I just want to do a quick audio video check. If you can hear me, everything's working well. Give me a smiley face or something. Okay, cool. All right, just making sure. All right, so your second step in this process is to multiply the first fraction by the denominator of the second. So multiply the first fraction by the denominator of the second fraction, which would be 2. So I'm going to say multiply, and what I do to the bottom, I'm going to have to do to the top. Something like cross multiply, you could think, but not the same thing, technically speaking. Okay? And then your third step then would be multiply the second fraction by the denominator in multiply the second fraction by the denominator of the first. How's it going, Carson? Okay. So now we're going to multiply the right one by k plus 1 and k plus 1 here. There we go, Andrew. Good to have you back, man. Okay, so now we just go to work here. I'll put those in parentheses. And now I'm just going to go to work right here. So distribute this. So now we start multiplying stuff. But the difference in the fraction that we did in the beginning and this fraction is we're just distributing this 2 into the k and the 2 into the 3. So 2 times k is 2k. And 2 times 3 is 6. And I'm just going to go ahead and write that over and then distribute the 2 into this and the 2 here. So 2k plus 2. Now I come to the right side and work that out. Plus, distribute this here, distribute this here, and I'd go 3k squared plus 3k. All over, and if I distribute that there and there, I'm going to get 2k plus 2. Now we have fractions that we're adding with the same denominator. And when we have that, then we can just simply add the numerators together. So this should always work out when you multiply this and this, this and this. It's always going to work out that it's going to be the same, like this. So then we just say 2k plus 6 plus the right side numerator, 3k squared plus 3k. And then we're going to put that all over 2k plus 2. Cool story, Olivia. I'm kind of in the middle of something, Carson. Don't make me call your mom. All right. So let's add like terms. So 2K and 3K are like terms. So we can add those two together. And we get 5K. And then plus 6 plus 3K squared. Sorry about that. And then we put that all over 2K plus 2. Now, we could put that in order if we wanted, like a quadratic equation, 3K squared plus 5K plus 6. But keep in mind, the only thing that you're going to factor out here is a 2. And then you're left with K plus 1, and none of that's going to cancel with that. So therefore, this would be my final answer. That's the first problem. So let's go to the next one now. Next problem would be number 4. So looking at number 4, let's follow the steps. Let's rewrite the problem with space. 3n. Correct, Kyle. If you cannot simplify it and cancel like we did yesterday, that's why yesterday we worked on simplifying and then we went to multiplying and dividing. If you cannot simplify it, then it's your final answer. And I'm just kind of saving us some time here. If we could factor that out and see what the factor it is with this, but I'm just trying to save us some time here and just let you know that that's the final answer. But always check it, though. Like on your homework, check and see if you can cancel. Just trying to save some time here. 3n plus 3 over 2n plus 2. Leave some space here. And then I say plus 3 over 2. You can always use the quadratic formula. I think that is, I'm not sure who that is. Is that Vic? I think that's Vic. You can always use the quadratic formula for anything to simplify to get your factors. But you would want to factor that. If it can't factor, then you probably don't even need to worry about what that would be from there. Okay, so then coming back over here, I multiply the first fraction by the denominator of the second. So multiply this side by 2. Multiply this side times 2n plus 2. Good day, Olivia. Happy birthday, by the way, Jake. And happy birthday to anybody else's birthday it is that I don't know. So now let's just start doing the math from here. I hope you're following this process here. So let's distribute. I'll put just parentheses around it. Sometimes we can see it a little bit better if we put parentheses around it. So distribute. That is going to lead me to this. 6n plus 6 over, distribute the 2n now, 4n plus 4 plus distribute this in here and get 6n plus 6. And guys, I don't have to do that again because it's just going to be this same thing. So I don't actually have to do the work again. It's just going to be that every single time. Yeah. Oh, sorry, Molly. I didn't see your comment. Molly, you always multiply by what the denominator would be. So, like, just for in these cases, the right one was 2. And we multiply this one times the left denominator, 2n plus 2 to both of those. Thanks, Taylor, for the help there. Does that make sense, Molly? Okay, cool. So, with that, let's say from here, I have like denominators now. So when I have like denominators, I can just add the numerators. So I have like, alike, and I have like and alike. So this would lead me here to this. 6n plus 6n is 12n. 6 plus 6 is 12. And it's over this. It's the denominator is going to be the same. 4n plus 4. Okay. So with that, I would want to circle this, but these look like a number could go into all of them, so that probably means it can be simplified. So let's factor a 12 out of this top one. Factor 12 out, and I'm left with n plus 1. So not only do I have to add them together, but I have to simplify them at the end. 12 times n plus 1 over, and then right here, factor a 4 out. And then if I factor a 4 out of that, I'm left with n plus 1. Then my question to you intelligent students would be, can I cancel n plus 1 and n plus 1? Okay. I actually can here. Very good, Tara. I can cancel these because this whole thing is being multiplied by 12, and this whole thing is being multiplied by 4, so I can cancel both of those. Good, Ellen. No worries, Chris. And then what is 12 divided by 4? Type it into the box. 12 divided by 4 is? Good, Molly. 3. Good, Tara. Give me a smiley face. Give me something that we're kind of halfway seeing this. Trust us, we got more problems. So just give me a smiley face like, all right, I'm kind of seeing this. Good, Vic, Adam, Ellen, Jamie, Tara. Good, Kenny. Good, Jake. Good, Chris. Good, Taylor. Catherine, Kyle. Good to see you, Catherine. Good, Karen. All right. That's most of you there. So then let's jump over here. Good, Dawson. Let's jump over here to number 5. All right. So again, first step, if I go back to my steps up here, good, Andy, I need to rewrite the problem with space. So I'm going to rewrite it as 2, good, Kenzie, 2 over 2n, and then leave some space here for this, plus n plus 3 over 2n squared minus 4n. So now we multiply the first fraction. If I go back to my steps over here, multiply the first fraction by the denominator of the second fraction. So if I come back over here, I'm going to multiply the first fraction by the denominator of the second one. 2n squared minus 4n. 2n squared minus 4n. Third step, I'm going to multiply the second fraction by the denominator of the first. So the denominator of the first one is 2n, so I'm going to multiply this side by 2n. 2n. And now we just go to work. So distribute the 2 here and the 2 here. That will leave me to 4n squared, and then 2 times negative 4n would be minus 8n. I put that over, distribute this 2n and into both of those. 2n times 2n squared is 4n cubed minus 8n squared. And I say plus, distribute this 2n to the n and to the 3. Imagine that being in parentheses. 2n times n is 2n squared. 2n times 3 is 6n. Question for the chat box. Do I have to multiply that again? Do that all over? Yes or no? Good, Kyle. I don't have to, because it's just going to be this right here if I did it correctly. So 4n cubed. Good, Terry. Good, Taylor. Good, Adam. 8n squared. Now I have like denominators. So I can add the numerators together. So I'm going to say 4n squared minus 8n plus 2n squared, that's the right side, plus 6n. I'm putting this all over that denominator of 4n cubed minus 8n squared. Okay, from there, let's add like terms. So what do I have that's like? I have 4n squared and 2n, and I have negative 8n and 6n. So 4n squared plus 2n squared would lead me to 6n squared, and negative 8 plus 6 would lead me to negative 2n. And I put that over 4n cubed minus 8n squared. Okay. Now, here's the thing here. This looks like, again, most of the time, if all of these can, obviously, if something can come out of all that, most likely that means that we can factor it. So let's factor this. Let's, on the top side, what can I take out of the numerator? Yeah, correct, Tara. They could all divide by 2, but we can just factor it, and that'll kind of take care of it all. What can I pull out of the numerator? Jake, don't do that. I'd have to kick you out. I can pull a good, Kenny, a 2n. If I pull a 2n out, I'll be left with 3n minus 1. Okay. And I can pull out a 4n squared from the denominator. And if I do that, I'm left with n minus 2. Ellie said, do you have to put the -1? I assume you're talking about right here, Ellie. And if you factor a 2n out of -2n, you're left with -1. Okay. Now we can simplify this right here. The 2 and 4 would cancel. 2 goes into itself once. It goes into 4 twice. This n right here will cancel. Remember, this is n times n, so there's really 2 of them. But if you mark off the squared, it just leaves 1 there. So then make sure you don't get confused in this. But we have then 3n minus 1, and you wouldn't have to put that in parentheses, but 3n minus 1 over, don't forget this right here, 2n times n minus 2. Okay? All right, number 6. Actually, I'm going to give you like 2 minutes. Work number 6, or 3 minutes. I'll give you 3 minutes until like 11:55 a.m. I'll give you like 3 minutes. I want you to work this one on your own without my help, and then I'll work through it. So try it on your own. Don't sit there be eating ice cream and doing whatever else you're doing, eating ice cream or something like that, Andrew. But work number 6 independently. Work it out. Hey, someone type into the chat box. There's something that we got to do here. It's an acronym that you got to do here. Someone type that in. What? Good, Tara. FOIL. Check your answer with Mon once you get it done. Give me a thumbs up, a smiley face if you got it correct, or even if you're on the right path. You were there. I just didn't give you enough time. Smiley face, something like that to show me, hey, yeah, I got it right. Good, Vic. Good, Tara. Good, Kenny. That's cool, Kyle. Good, Jamie. Vandy. Good, Jesse. Good, Catherine. So, just to walk you through, my first step was I wrote it with space. Okay. I wrote it here with some space. 3n over n plus 1 plus 3 over 2n. I multiplied the left side, the first fraction, by the denominator of the second, which is 2n minus 1. I multiplied the second equation by the denominator of the, hey, we'll talk about that, Molly. I multiplied the second fraction by the denominator of the first and got this set up right here. I then distributed 3 and got 6n minus 3 over here. I got to FOIL this, so first is n times 2n, which is 2n squared. Outside is negative 1n. Inside is 2n, and outside or last is 1 and negative 1, which is negative 1. Good, Molly. Over here, I distribute 3n plus 3, and then I kind of cleaned that up there and got 2n squared plus n minus 1. 6n plus 3n, you're adding exactly what you said, Molly, so it's just 9n. It's not multiplication, so you don't square the n. And then 2n squared plus n minus 1. Now, some of you may be saying, well, how do I know not to simplify here? Well, think about this. This trinomial comes from this binomial. So actually, you could see it like this as well. 9n over n plus 1, 2n minus 1. That is the binomial that got us this trinomial. And as you can see here, even with this, I cannot cancel anything. All right, thumbs up. Halfway done. Halfway through this one. We good? Give me thumbs up, smiley face, something. Still alive? Still breathing? Good, Cherry. Good. Catherine, Kyle, Ellen. Good, 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 good. All right. Going to the back side now. Okay. So backside, we now go with subtraction. Okay, so we added the front side, we subtract this back side. So with this, we ask ourselves the same question. Are my denominators the same? In this case, yes, they are. So I'm just going to subtract the numerators. So I'm going to say 3 minus 2x over 4x cubed plus 8x squared. So in this case, notice that this is a monomial. So the subtraction just applies directly to it. But if this was a binomial, we would have to distribute that negative in, which we'll get to in one of these problems down here. Okay. So here we have 3 minus 2x. Now, here's what I know. I know I can factor something out of this, but I cannot factor anything out of this numerator. So that is my final answer. I could see my answer written like this, though. 3 minus 2x over 4x squared over x plus 2. I could see my answer just like that. Okay? Vic, I'm assuming you're good. So then looking at 8, my first question, are my denominators the same? Yes, they are. Since they're the same, I just subtract the numerators. 2 minus 3v. So you guys got lucky with these two on the notes. And then 4v squared plus 4v. That is correct. That is the answer. And then right here, I can't factor anything in the numerator, so it's in simplest form. So that is my answer. But I could see it like this on a test. 2 minus 3v over 4v times v plus 1. Because that's them factoring the denominator. But obviously there I can't factor anything like that. Your ones on your homework are not as easy as that. So just be mindful, and that's just sometimes the way it works, is that the ones are not. But I'll take any questions over those. Actually, if you have your homework nearby, grab that, rip that off real quick. If you don't, then you can just like come back later and kind of watch this. So this is your homework. This is 4.4 homework. So if I'm back here on 7, it didn't give us this beautiful, notice this is a monomial and this is a binomial. While my denominators are the same, this would have to be worked like this. 3r minus 2 minus, and then you'd have to put this r plus 3 in parentheses and then put everything over 8r squared plus 8r. And again, this is the homework. I'm just giving an example because I'm not trying to confuse you. I'm not trying to like give you an example on the notes. It's not on the homework. So I'm going to go ahead and just work this homework problem out. So anytime you have a binomial here, you have to write it in parentheses with that negative like that, because that negative has to go in there to both of those. So I'd have to distribute this negative here, and really that's a -1. So then I'd be at 3r minus 2 minus r minus 3 over 8r squared plus 8r. And then I take care of my like terms. And I get the answer. 3r minus r would be 2r. -2 minus 3 would be -5 over 8r squared plus 8r. And that would be the answer there, because the numerator cannot factor. So, but keep in mind, you could see the answer as the denominator factored. So that's, I wanted to show you this just like, because on your homework over here, you're going to have to, when you bring that negative down, you just can't say minus a minus 1. You're going to have to say minus the quantity of a minus 1 and then distribute the negative in. Give me thumbs up if you're following me on that. The difference between them on our notes, we just had monomials, but on the homework, you do have a couple binomials. Give me thumbs up if you're kind of following me on that. Okay, a couple of you are. Cool beans. Okay, so that's the homework. So let's go back to the notes. So I saw a couple questions of like, hey, is this the final answer? Yes, that's it. This is it, and this is it. Again, it's a little bit easier due to the fact that we have a monomial here and a monomial here. No, Kyle, we don't have to factor the that's what both of those are. You don't have to factor it because it's not going to simplify anything. But your answer choice on a test could have it factored, just trying to trick you up. So that's why I put this or statement here. So it could is this or could be that. On your answer key, it could be factored. So just wanting to prepare you for that, if that makes sense. Okay, cool. All right, jumping down to number 9. Now notice with number 9, do we have like denominators? The answer to that would be no. So we're going to follow the same procedure that we did on the front side with addition. But there's one exception with the with subtraction, and that exception is what I just showed you on the homework. That exception would be distribute the negative. Distribute the negative or the minus if bigger than a monomial. And that will save you a lot of time. Sorry about that, my mic was off. So first step, I'm writing it with space. Sorry about that, guys. So first step, bring this down, write it with some space here, just like I did there. Think about that. If I did this in total silence, I think most of you could still probably get it. If I just like muted the whole time and just worked through it all, you could probably, most of you guys could probably manage. All right, next step, multiply the first fraction by the denominator of the second. So let's multiply the left side times k plus 3. And the denominator by k plus 3. Bella stays like 5 minutes behind. And then multiply the right side by 4. Oh, wrong color. Did I show you guys Rocket yesterday? I don't know if I did. Did I show you guys the dog? I didn't. Rocket? This is Rocket. Hey, boys. Come here. Come here, boys. Sit. No. Back. Back. Come here, boys. There's a boy. Back. Go back. Oh, there we go. Sit. There he is. He's a good boy. Is he a good boy? Who is it? Go get him. Who is it? All right, chill out. All right. Sorry. Okay. Bella's asking if she's behind. Sorry, I didn't mean to, drop the hammer with the loud barking. No. Oh man, Bella is she is lagging. It's a constant lag with Bella. All right. So Karen, you're a pervert. All right. So let's distribute 4K into this. We got to finish. Just a few more pairing. I'm telling you, Karen is, man. All right. So we distribute 4K in. We get 4K squared. $4K squared plus 12K over, and then let's distribute with the denominator, 4K plus 12. And then I say minus this right side, 8K. And then again, I don't have to distribute that. I can, but I'm going to get the same thing, 4K plus 12. Now, if this was a monomial here, I would have to put it in parentheses and distribute the negative. But since it's not, I can just rewrite it as 4K squared plus 12K. I can just say minus 8K since it's just a single term. All over my same denominator is 4K plus 12. So I had like denominators. So that allows me to just subtract it. That then takes me 12K minus 8K. That would take me to 4K plus 4k squared, excuse me, plus 4k all over 4k plus 12. And then I can, obviously a 4 will go into all that. So if I factor a 4k out from the numerator, I get k plus 1. If I factor a 4 out from the bottom, I get k plus 3. And then from here, the 4's would cancel, leaving me with k times k plus 1 over k plus 3. Now, I'm putting that as my answer, but you could also see this as an answer. K, so I'm going to say or here because they try to trick you up here. K squared plus k over k plus 3. That could easily be an answer. That's just them distributing the k back in, okay? So just trying to prepare you for both. So if you get this and the answer key looks different, it's probably this right here. They probably just distribute it back in, just kind of preparing you. Sometimes they look for different things. Okay. Let's jump over here to number 10. So looking at number 10, I'm going to rewrite the problem. 4m over 4, and I'm going to leave some space here, minus 4m over 2m minus 3. Someone type in the chat box, what am I going to multiply the left side by? What am I going to multiply the first fraction by? Type it into the chat box for me, please. Good, Vic. Anybody else? I'm multiplying the first fraction by the second fraction's denominator. So times 2m minus 3, 2m minus 3. And then someone besides Vic, type into the chat box what I'm multiplying the right side by. What would I multiply the right fraction by in order to get like denominators? Good, Kyle. Good, Chris. Look at you, Chris, getting in on the action. Multiply it times 4. Good, Catherine. Catherine's actually talking. Good, Kenny. The first fraction is denominator. So then from there, is Lonnie still here, or did Lonnie dip? There's no way Lonnie's still here. Distribute, distribute. He's probably saying, I'll just get this all from Karen. Or not Karen, excuse me. Not Karen. Catherine. Lonnie, you still here? All right. Yeah, I'd say he's not. So 8m squared minus 12m over, distribute here, 8m minus 12. Right, Taylor. Minus 16m over 8m minus 12. So again, since this is a monomial, guys, we can just attach that. So it look like this. 8m squared minus 12m minus 16m all over that 8m minus 12. Negative 12 minus 16 would lead us to 8m squared. Again, sorry, I'm getting a little ahead of myself, but we had like denominators, so therefore we could just subtract those. And then I have like terms in negative 12m and negative 16m. So 8m squared, negative 12 minus 16 is negative 28m. All over 8m minus 12. Now 8 won't go into 28, but 4 will. So I could. So this looks good, but I can obviously factor something. So 4 will go into 8. I can factor a 4 out of there, and I can factor a m out of the numerator. That would lead me, if I factor a 4m out, I'm left with 2m minus 7 all over, and I can factor a 4 out of the denominator. I'm left with 2m minus 3. And then here I can cancel 4 and 4. And then that leads me to my final answer. I'm just going to write it right here. M times 2m minus 7 all over 2m minus 3. Or you could see it as 2m cubed minus 7m over 2m minus 3. You could see it both ways. I'm fine with either way on your homework, guys. I'm fine with either way on your homework, but just be prepared for both ways. Okay, 11. So 11, same thing. First step, rewrite it. 2 over x minus 4, and then minus 3 over x plus 1. Just so I know you're still with me, someone tell me what I multiply the left or the first fraction by. What do I multiply it by? What the actual answer that I'm going to write here? Good, Vandy. Good, Vic, Kyle, Taylor, Tara. Very good. Multiply times x plus 1. What I do to the top, I have to do to the bottom. Good, Chris. And then same thing. Someone type in what I multiply the right by. Good, Kyle. Good, Tara. Look at you, Ellen. Bella. Bella's in the Bella. You're actually caught up. I'm loving it. X minus 4. X minus 4. Okay, now we just go to work. Distribute the 2. Distribute the 2. That gives me 2x plus 2 over. Now I have to FOIL this. So first is x squared. Outside, x times 1 is 1x. Inside, negative 4 times x is negative 4x. And last, negative 4 times 1 would be negative 4. Then I say minus, distribute 3 here, and I have 3x minus 12 over, now again, I don't have to fool that. I've already done that here, but I'll clean it up here. So x squared, and then what is 1 minus 4? 1 minus 4 would be negative 3x minus 4. Okay? Now, notice what we're about to do with this minus here. I have like denominators, so I can put the numerators together by subtraction. So, but notice this right here. I need to say 2x plus 2 and then minus the quantity. Since that's greater than a monomial, I need to say minus the quantity of 3x minus 12. Be careful with this, guys. Be careful, because if you make a mistake, that's probably where it's going to be on this backside. And then I say that's all over x squared minus 3x minus 4. I then distribute this negative in here, which just changes the sign. So now I'm at 2x plus 2 okay, sorry, Taylor. So Taylor asked, how did I get this negative 3x? So this FOIL right here is the same as this FOIL. And what I did, I just simplified this right here, Taylor, over there on that other side. So 1 minus 4 would be negative 3. You follow me where I got the negative 3 at now, Taylor? Well, it's not a matter of simplifying it, Taylor. It's a matter of just adding like terms. In this case, if you left it like that, which remember though, when you FOIL something, it's going to take you to a trinomial where you have 3 terms, because the middle terms are always going to add together. So technically speaking, if you had it like this, that's technically still right, but simplified means that all terms are added together. Okay? So then that would be minus 3x plus 12. All over that same denominator as x squared minus 3x minus 4. My pleasure, Taylor Rice. My pleasure. Shout out, hashtag Andy. So I now add 2x and negative 3x. They're like terms, and then 2 and 12. Okay? So then from there, 2x minus 3x is negative x. 2 and 12 is plus 14. And that's all over that x squared minus 3x minus 4. Since I cannot factor anything out of this numerator right here, that is my final answer. All right, last problem. Work it out on your own independently, and then we'll check your answer with mine. I'll give you 4 minutes. That should be plenty of time. So at 12:34. Anybody need more time? Coming up on that 12:34. Okay, check your answer with mine for number 12. Give me a thumbs up or a smiley face. Hey, I got it right. Anybody? Kenny. That's what I'm talking about. Good, Vic. Good, Adam. Kyle, good. Good, Jesse. Good, Tara. It's all right, Taylor. Thanks for your honesty. Let's see if we can find mistakes or anyone who did it. So I'm going to walk through it. First step you need to do is to rewrite the problem. 3 over 2, leave a space, minus 4 over 2x plus 2. So then we multiply the first equation by the denominator of the second one, 2x plus 2, 2x plus 2. We multiply the right fraction or the second fraction by the denominator of the second to get like denominators. When we do that, we get 6x plus 6 over 4x plus 4, and then 4 times 2 is 8, and then the same denominator. Since I have like denominators here, I just put the numerators together. Remember, be careful on that one thing. Since that's a monomial, I don't have to distribute. I can just bring it down with it. 6 minus 8 is 2. So 6x minus 2 over my same denominator, 4x plus 4. And then notice anytime all four things something will go into that, that means it'll factor. So factor a 2 out here, I'm left with 3x minus 1. Factor a 4 out in the denominator, and I'm left with x plus 1. And then 2 and 4 will simplify to 1 and 2, or 1/2. And then that would take me to 3x minus 1 over 2 times the quantity of x plus 1. Or you could see it as with the 2 distributed back into 2x plus 2. Questions of me? Adam asks, when is the next live video? Okay, so I will actually send that out. I'll send that schedule to you as soon as I get it. I have it tentatively scheduled, okay, for Monday at 11 a.m. Okay, so I have your next live as lesson 4.5 at 11 a.m. And that's on Monday, March 23rd. So next live, and I'll send you the full schedule for the whole week. I have it here. I just want to, I'll probably send it on Fridays for the next week. I have it all done, but everything's tentative because if something goes crazy in a class and I can't, then it may mix up. We'll try to stay pretty consistent, but again, it may switch up from time to time. And Karen, I was working a problem when you asked an hour ago. Right now would be the time to ask. Hey, Tara, yeah, I don't mind to go back to the first two problems of the paper. keep in mind, you can always go back and watch, though. You can do that. You can always go back and watch those. But there is the first two right there. Or you can pause the video at any time as well. So next live is upcoming Monday, lesson 4.5 notes, 11 a.m., March 23rd, which is on Monday at 11. And again, I'll send that schedule out to you. Not a problem, Adam. Any other questions of me, feel free to, you guys can start following off. I hope you guys are having a great quarantine time. This is crazy. I think it's crazy for everybody, but just try to take advantage of it as much as you can. I appreciate it. I can't tell you how much I value the number of people at these live sessions. That it means a lot to me that you are here and that you're watching me work through this. So I appreciate it so much, more than what you know, because that simply means that you care. So I do appreciate that so much. Not trying to give too big of a speech here, but I do appreciate you all being here. I hope they help, Taylor. I really do. I hope they're helpful, that they're not just, man, I got to spend an hour and a half of my time like watching or talking to Mr. Ipoc. So I hope they are helpful. I really do. I am. I'm doing any questions tomorrow at 10:30. Thanks for mentioning that, Taylor. So I do a live session. Oh, sorry about that. So I do a 10:30 a.m. on Fridays. Every Friday I'll do a 10:30 a.m. live session. So if you want to come and ask me any question, understand there could be other kids in there asking different questions, but I will be here live on Friday. Oh yeah, absolutely. Same thing. And that's my goal, is that like for this whole thing. Yeah, yes, correct, Jamie. Yeah, we will go over any question you have on Monday as well. So I'm completely fine with that, just like we did today. And as I was saying, my goal for this is that it's like we never disappeared from the classroom. So like my goal is that, hey, you come in here, questions on the homework. The difference is we're not grading anything right now. So that makes that's like our only difference. But everything else, hey, we're doing notes. You got homework. You got to knock it out. It's in your binder. It's in your folder. Keep up with it. And then again, as I said the other day, I have no clue when we come back to school. Hopefully it's April 14th, just because teaching is not as cool without the kids. Although I love being here home with my family, you guys make this job so easy, so fun, so entertaining. So, but yeah, keep it normal. You got questions on Monday, feel free to ask them to me. Any other questions today? Cool beans. Feel free to just start. Guys can start signing off. I'll see you guys or talk to you tomorrow morning, or I'll see you Monday at our live session. Be safe, be careful, try to stay indoors as much as you can. Karen, why are you still on here? You were complaining about having to be here, and then you're here 10 minutes after I got done teaching. But know that I love you, Karen, and I miss you.